Everyone, Jerry from Llama Index here, and today in this notebook, we'll show you how to write a financial report generation agent system. And so we'll show you how to first index a set of financial reports or 10K statements on Apple and Tesla, and then actually use this to compose an agent workflow to perform financial report generation. And you're just going to be able to create, a simple report containing both interleaving text and tables. So we'll use some of the core concepts that we outlined in the last video on structured outputs, and then combine that with actually building a simple research and writing agent system. There's both a research agent as well as a writing step that will compile or take the existing compiled research and build the financial report. So LlamaCloud as our end-to-end RAG platform will serve as basically the indexing retrieval layer. We'll be able to index the existing set of 10Ks with LlamaCloud and then provide some set of retrieval endpoints on top of it that let you both fetch chunks and also entire documents from these reports. And so, these reports, like these 10Ks, can contain a variety of different elements, text, tables, and sometimes images and diagrams. And on top of that, we'll use that as a knowledge base and then build using Llama Index workflows an agentic workflow that can do research and also writing. So let's take a look at the image right here, just to give you a sense of what this consists of. So in this diagram, we'll start off with the user query. First, we'll query this knowledge base. And then basically what's gonna happen is this query will get passed over to a research agent. So this research agent is going to basically be like a function calling or React agent loop. And given the existing question, its main goal is to continuously call the knowledge base and continue fetching information until it feels like it has enough context pulled in. So each tool is basically architected like the following. It's going to launch a query to the knowledge base, store that retrieved context in some sort of temporary cache, and the response from the tool will be this is the thing that I've roughly retrieved in a summarized form. And then if it's like a multi-step process, it'll keep calling the knowledge base, storing the research, and then getting back the output from the tool. Once it feels like it has enough, then it'll be able to pass it to this next step of report generation. So in the next step of report generation, it's really just a single LLM call with structured outputs. We'll take all the compiled research from the previous step, dump it into the prompt, feed in the user query, and then using the power of structured outputs, we can generate a report like this. And so, this is a pretty loose definition of a report, of course, because this is just like a simple response. And of course, a more challenging problem would be to generate something that's multiple pages. But here you can see, we'll show you how to actually generate something that contains like a text block and then also renders a table in the middle, and then more text blocks. And so it's a pretty simple workflow that shows you some of the basic patterns of report generation. Great, so given that, let's first we're gonna download 10K files from Apple and Tesla, and then we're gonna upload these documents to LlamaCloud. And so I've already created an index over here containing these 10K documents, but all you have to do is go into this main page, create the index, upload your files, say right here, select your data sync, select your embedding model, select your parsing settings, and then select your chunking settings. Generally, you can choose what parsing settings make the most sense given your performance cost budget, but I recommend page level chunking. So, you just have to set the segmentation mode equal to page and then chunking equals none right here. So going back into the Apple Tesla 10Ks, this is just an example again of what the document looks like. So here is the source document. Here is the parsed representation. And we're able to parse the entire document into a markdown format, including the tables, thanks to Llama Parse. And then this is what the chunk representation looks like. And you can see here we have page level chunking. So every chunk is actually just an entire page. So besides the text, you also have a bunch of metadata on this page. So we've already downloaded the files. The next thing, and this is a bit specific, is we're going to be using GPT-4o as a model. GPT-4o has a bit of a custom tokenizer, and so usually this doesn't really matter, but because we're really focused on stuffing the prompt as much as possible, especially given a lot of research, I think we're going to want to set this as a token setting, as a global setting, so that we don't run into context overflow errors down the road. So you just have to set global tokenizer right here. Afterwards, this is just some other basic setup stuff, and then we'll walk through this. We're going to be using GPT-4o as the LLM, as well as text embedding 3 large as the embedding model. And then the next order of business is to, we've already loaded documents into LlamaCloud, is to hook into this index and then define like the retriever and tool wrappers on top of this index. So you just have to import LlamaCloud index and then specify the name and project name and organization ID of your index. So this is just based on what we define in the other tab. You also have to define the file retriever. So in this section, we're going to define the 2 different retriever endpoints. One is we're going to define a retriever that can return entire documents. And so this just requires a special retrieval mode called files via content. And you can see we set a files top k equals 1. And so this doesn't return chunks, it returns entire documents via semantic search. And then the second thing that we'll define is chunk retrieval. And so this is your standard kind of like top K based, we're going to find the top K chunks based on embedding similarity and then return that. Having 2 levels of granularity in your retrieval, we found is actually a pretty interesting idea in terms of providing research tools for the agent. Because then the agent has the ability to basically dynamically decide if it really needs all that context by pulling in like an entire document, or if it really needs just specific chunks of a document. And so this can potentially help you both like save tokens relative to always pulling in the document, but then sometimes when you actually need the entire document for analysis, it's able to have the flexibility to do that. After we define these retrievers, we're going to define retriever tools. So we're going to wrap these Python functions into tool objects. And so all we have to do is define 2 Python functions, a chunk retriever function and a document retriever function. We annotate it with type annotations and doc strings. And you can see here for the document retriever function, we say only use for research questions that may require searching over entire research reports, as opposed to just specific chunks. And this is actually a prompt that would end up getting stuffed into the LLM prompt window to tell it to only use document retrieval when necessary. And then we are going to define a chunk retriever tool and doc retriever tool. So this just is using our function tool abstractions, and we plug in the chunk retriever function and doc retriever function. Now that we've defined these tools, they are basically going to be tools that are going to be used as part of our research agent, which is just one step of this overall report generation workflow. So let's actually get onto this piece. Let's get onto the main piece of building a report generation workflow. This workflow will contain roughly the following steps. There's going to be 2 main steps to report generation. The first is research gathering. In the research gathering phase, we're going to be using the research agent in a function calling loop, where the agent can either do chunk level or document level retrieval to gather relevant information about a query and store it somewhere. And then after the agent feels like it's gathered enough info, then it can move on to the next phase. The second phase is report generation. So after that you've done the research and stored all the context, the second step is you can actually generate a research report given the pooled research. And so right now, the second step is actually relatively simple. We're just going to do a technique of just trying to stuff as much stuff into the prompt as possible, and I'll show you how that works in just a bit. Now, before we actually define the workflow, we're going to be defining the data model basically for the output. And you can see it's basically modeled as a Pydantic schema. And so you see here, we define a class called report outputs. And this is a Pydantic model. Basically, can contain a mix of both text and table blocks. And you can see blocks can be a list of both text blocks as well as table blocks. And then there's also like a nice little render function. So any instance of a report output can be rendered in a Jupyter notebook. A text block is just a Pydantic model that contains a text attribute. And then a table block should just be this. Should really just be kind of a Pydantic model that contains, the column names, caption, and then the rows. And so this is actually a little bit more structured than the text block and assumes the table is in like a 2D format. But assuming that we're actually able to, create these tables, you can, for instance, like extract all the tables into a data frame. So this is going to be the final thing that we actually produce. It's going to be a structured object of type report output with text block and table block. And so instead of, again, just giving back an unstructured chat response, the goal of the report generation agent is to generate this. Okay. The next step here is we are going to now define a system prompt for the report generation agent. And basically, you can see your report generation assistant tasked with producing a well-formatted report given the parse context. And so you're going to be given context from a bunch of reports or a bunch of information that the research agent has collected. And then, you have to output your response as a tool call that conforms to this Pydantic schema. So we're going to be using function calling capabilities of an LLM or tool calling capabilities to ensure that the output actually conforms to this structure. And to basically add on to this, to really make sure the LLM gets what we're talking about, we actually output an example, like report output on some like toy data, just to give it a sense of what we expect. And then this system prompt is actually going to go into a special LLM class that's a wrapper on GPT-4o. And we can see we define what we call a structured LLM. By basically attaching an output class onto an LLM, you can basically then ensure that every output from this object is structured as opposed to unstructured. And we'll show you how that works in just a bit. So now that we finished defining both the Pydantic model as well as the variables, we're now ready to define the full report generation workflow. So we are going to be using Llama index workflows to define this report generation workflow. And if you follow some of our earlier videos, you'll see that it bears a lot of similarities to how to define, for instance, like a function calling loop, having that loop use the right tools, and then basically generate the final response. And so we'll define a report generation agent, which subclasses a workflow. Basically, the entire workflow is going to be a Python class. We can take in some initialization variables and then basically define the different steps of a workflow as Python functions that are async in nature. So in terms of initializations, we'll take in the two tools that we define above, the LLM as well as the report generation LLM. If we go on into the first step, it's just called prepare chat history. It takes in the start event or the first event of the workflow. And then we are going to, basically add the current query as a chat message to the memory module. And so this basically is a simple step. It just kickstarts the overall process. And then it's going to return the input event, which goes into this function called handle LLM input. It takes in the input event, emits a variety of different types of events actually. And this is actually pretty much the main reasoning loop. And if you have followed some of the function calling implementations, you'll see this is basically a more specific version of how to implement a general function calling agent or a general function calling loop. But we'll walk through this and hopefully it's actually pretty intuitive, which is, on the first time around, we have the existing user message. We're going to call llm.chatWithTools. And so this is a wrapper around the function calling capabilities of LLMs, where it can take in existing tools as a parameter as input, along with whatever the current chat history is, and then get back the response. The response, you can actually, because you called chat with tools, you can parse the tool, the response to see if there were any tool calls being made. And so, because you specified these tools, you can call this function, see if the number of tool calls is non-zero. So if the tool calls is non-zero, that means that it still wants to call these tools to actually continue doing research and basically getting back the response. And so for tool call and tool calls, we'll basically log this, but then basically we're going to go on into this block right here. For tool call and tool calls, if the tool call, that tool name is the chunk retriever, we're going to call the chunk retrieval event. If the tool name is the document retriever, we're going to call the document retrieval event. And if it's invalid, then we're going to throw an error. And so as long as there are non-zero tool calls, we're going to continue calling the downstream events. That's going to allow us to do chunk level and document level retrieval. If there are no tool calls, which means the research agent actually feels like it's done, then we're going to move on to the report generation step. All the content is stored in the context now, so we're going to pass this all the way to the last step to generate the final report. If we just take a look at the chunk retrieval event, which both of these are actually handled by the same function. You can see there's an async function called handle retrieval, which listens to both the chunk and document retrieval events. And really the only difference between the two is that depending on the type, we're going to call the chunk retriever tool or the document retriever tool. And instead of actually stuffing all the retrieved context into the chat history, which risks kind of blowing up the agent's conversation memory, what we're really going to do is we're actually going to synthesize. We're going to use what we call a summarizer. And this is just a module that Llama Index has as one of the core capabilities that we have. And it's just going to synthesize a response to this query, given this context. And the goal is, the thing that we're going to put back into the agent's chat history is actually the condensed summary of what it retrieved. So it's you looked up on Google, found a bunch of information, wrote it down in a notebook, and then the thing that you return back in terms of what you store in your head is just I looked up stuff in Google, but not the entire mess of text that I found or wrote down in the notebook. So that is the thing that you're actually going to put into the memory is the synthesized or summarized response. But the actual retrieved chunks is going to be stored in the current context cache, and it's going to be stored in a variable called stored chunks. So we basically store the retrieved chunks in this variable, and we're going to be using it all the way at the end when report generation happens. So after we handle the retrieval, we're going to pass back an input event with the input equal to whatever the current memory is. And this basically loops back all the way to the beginning of handle LLM input. And it's going to keep calling the chunk or document retrieval items until it feels like it's done. And then it's going to finally run out of tool calls and call the report generation event. In the final report generation event, what it's going to do is I'll walk through this in a more step-by-step manner because here it's really just one line of code. But basically, it's going to somehow call this report generation summarizer. It's going to call synthesize on that. And what it takes is the current query, as well as all the context or all the chunks that you stored through the research agent, and then it's going to generate the final response. This one line, it's pretty easy to use, but it might feel a little bit like magic. What we do know is that given the query and given the some list of context, it's going to be able to just somehow magically synthesize all that information, no matter how big it is, even if it overflows the context window of GPT-4o, and then give you back the response. And somehow it's going to do that in a way that's also structured and actually obeys the report output schema that we outlined before. So let's go into how that actually happens right here. So if we go all the way back into the initialization function, we'll see a few things. First is that we are using a module called tree summarize. And so this module is basically one of our response synthesis modules. You can see it's basically over here. We import tree summarize from Llama Index response synthesizers. And tree summarize basically takes in a query and then takes in some set of context. And it's actually like a special abstraction in Llama Index where no matter how many context chunks there are, no matter how many context chunks there are, we are going to somehow figure out a way to do some sort of like hierarchical map reduce approach to first like generate an intermediate answer per chunk and then hierarchically combine those chunks until you get back the final answer. So we came up with this technique all the way back in the GPT-3 days. And then, it's basically like a kind of way to bypass, or for you as the developer to bypass the pains and headaches of having to deal with like context window limitations of LLMs. So this will conveniently help bypass a lot of that for you. So that solves step one, which is, you've done a ton of like research, you got a bank of context, and you have a query, and you just need to figure out how to like, throw all this context plus the query into a context window and get back the answer. The second piece is notice that the LLM variable here is not just a standard LLM call, but it actually takes in the report generation SLM. And SLM here is just a variable that is passed in here, but basically we're expecting the structured LLM. If you recall back here when we define like the report generation LLM, we first define the standard model call OpenAI GPT-4o, but then as a second step, we define report generation LLM as structured LLM. And this is what this is the result of actually attaching an output class to the LLM object. And that is what gives us report generation SLM. Given an input to report generation SLM, it doesn't just get back a chat response, it actually gives back an entire structured output. The final result is that if we go all the way back here into looking at the response, you've set up the summarizer, you've equipped it with a bunch of context, and because you also initialized it with the structured LLM, the final output is going to be structured. And so it's going to basically be something that adheres to this like report output. So now that we've defined the report generation agent workflow, we're now ready to test our report generation agent. We initialize it with the chunk document level retrievers, the LLM, and the structured LLM for report generation. And then we're going to run it on a sample question. So the first question we're going to run is tell me about the top level assets and liabilities for Tesla in 2021 and compare it against those of Apple in 2021. And just tell me which company is doing better. So you can see here, it's first calling the tool with the document retriever tool to get Tesla 2021 financials. So it's fetching the entire Tesla 2021 document. And then it's fetching the document retriever tool for the Apple 2021 financial report. This is the research agent step. It's going to realize that it has all the information it needs, and then it's going to move on to the final report generation process. All right, and so this is basically what the final report looks like. We call response.render. So this is basically the result output object. That's a Pydantic model. We got the response, and then we call, if you remember, there's like a render function on it that basically displays both the text and tables. And so this actually shows you the final response. And you can see this is one text block. These are two different table blocks and represent the respective, like assets and liabilities or financial standings of both companies. And then finally, there's another text block. And so even though this is, and there's some like misformatting right here, but it's fine. But basically there's like, even if this is a very simple report, it shows you how basically this report generation process works. Because this, due to structured outputs, we're actually able to lay out some sort of like document that contains a text element, but also table elements. Now, let's just try one more question, and let's just run something like, give me the gross margin breakdown of Apple in 2023. Right. And so you can see here, it's actually calling like the chunk retriever function, maybe because it thinks that the gross margin can be found in like a specific chunks of these documents. And in this case, it would actually be correct because that really is just about like a specific number. And so let's actually see what it says. All it did was do one research agent call, and then we're going to take a look at the response. And this response is actually reasonably detailed. And so you can see that the gross margin breakdown provides insights into the financial services. Here is basically a table of the products, services, and total gross margin. There's some more text right here. And then this is basically a percentage-based analysis. So you can see here, like, it's actually starting to get somewhat report-like, right? This one, once you like extend this a little bit, make this a little bit longer, this is basically just like a full-on document that you could generate and contains all the elements that you need to actually produce a report. So that's basically it for today. Thanks for watching, and we'll see you guys next time.